Done. Still working. No one answered me. Thank you.
Friday.
Amen. All right, how about now? Tell me what you know about number one.
It's single.
It's single displacement. Okay, I just asked what you knew about number one.
Oh.
Okay, so it's single displacement. So what are we going to do on the test Tuesday? And by the way, we will be testing Tuesday because apparently the PSAT is on Wednesday, and multiple of you will be in testing on Wednesday. So we'll be testing in here on Tuesday because I'm not dealing with makeup testing for like 6 or 7 of y'all. I'm just lazy that way because I'm not staying for an hour and a half after school to do makeup testing for y'all. So we'll be testing Tuesday.
When were they going to let us know about that?
According to the email I got from Ms. Foy, those of you who were testing have been told, and y'all were supposed to tell me that y'all were testing.
Yeah, she didn't tell us that, but hey.
I didn't really.
It's largely the juniors. It's not sophomores, so it shouldn't, I don't think, you're on the list. Let me see, let's see if I can find the email.
What did you miss on Tuesday?
Then you just don't take it right. So Chris, Alex, Elijah, Arian, Diamond are the ones that are on this list. Now, that's not to say that there aren't others who can take it, but those are the ones that were emailed to me last night that are on the list. It have apparently either been signed up or are planning to take it. All right, so those are the folks who are on the list. And I'm just not planning to spend time with y'all after school because some of y'all are slow test takers. I don't plan to be here till after 5 o'clock doing a makeup test on this because we have to do it over 2 days. So, and next week I have no days to test. The following week I know I have at least one afternoon after school for hand therapy. So we're just going to test Tuesday. So if we look at number one, it's single displacement, right? So what's the first thing we did? Find the oxidation number. So what's CR? 6. What is F? -1. What's I? -1. Now, remember what I told y'all, and everybody always forgets this, but when you look on your periodic table, not your periodic table, your oxidation sheet, when you look at F, Cl, Br, and I, it has all that -1, +1, +3, +5, and +7 I told you the only oxidation number we're using right now is -1. So y'all are using the negative oxidation number for those. So +6, -1, -1. So who's switching? F and I. So you're going to get CR with who? And then F will be by itself. Now, given there's no polyatomic ions over here, does that 6 or 2 get to come across? No. This is a compound. So what do we always do when we have a compound? Crisscross. So +6, -1. Bring our 6 down. That's by itself. What do we ask ourselves? Is it diatomic?
Yeah.
So we put a 2 there. Okay, I'm going to get rid of this and that. All right, is it balanced? No. So if we balance it, we're going to say what? What do we need? Yep, because there's 6 I's. So we need a 3 there to make 6 I's and 3 on the F to make 6 F's. Okay. All right, number 2. What counts number 2? It's combustion. So what do we know if it's combustion? CO2 plus water. You can say it either way. Okay. So do we have to do anything for that one? Just balance. All right. So when we look at this, how many C's do we have? We put a 6. How many H's? So we put and we get 12, and we get 7, and we realize that's 19. I can't work with 19. So we quickly figure out, okay, I need to get rid of that, rid of that, rid of that, and then we need to put a 2 here. So 2 times 6 is 12. So we're going to put a 12. 14 times 2. I already got a 2, so I just need a 14. I don't even need to know what it is. All right. 2 times 12 is 24. 14 times 1 is 14. 38. What times 2 will give me 38? 19?
Yeah.
So 19. Questions? All right. Let's get rid of that and make myself a little space. All right. So antimony 5 oxide. So SB has a 5. Oxide has a 2. So 2 and a 5. Plus AG has a 1. Phosphate has a 3. Bring my 3 down and my 1 down. All right. What kind of reaction is that? Double. Okay. So who's switching if it's double? AG and SB is one answer, or you could have said O and phosphate. All right. So we're going to put SB with the PO4 and AG with the O. Since those are compounds, I only brought over the 4 because it's part of the polyatomic ion. So plus 5 and minus 3. 3 and 5 plus 1 minus 2. Bring our 2 down. Get rid of those. And we're ready to balance. So who do you want to balance first?
SB.
Sure. How many SBs? How many over there? So we put a 3 and we put a 2. So how many SBs did I make? And 6. So we're good there. How many O's did I make?
15.
Did I make 15?
Yeah.
All right. How many AGs did I make?
30.
Did I make 30? We put a 10. How many PO4s did I make? How many do I have? We're good to go.
If after the arrow, could you put ABO before the
Sure.
stuff?
Sure. Questions about anything in the opening? All right. Anything on the papers I handed back? Oh, I told you I'd tell you the bonus question. And those of you who have not done it, y'all just can't do the bonus question on that lab. You had Fe2S3O12. If you gave me that, you got 1 point. If you told me iron 3 sulfate, you got 2 points. If you gave me this, you got 2 more points on the bonus. Those are what the points are worth. Okay? You only got 1 point for that because you didn't really do anything different than you did in the first 5 questions. Okay? So that wasn't worth a lot of points. But these two were figuring out that you had a polyatomic ion and putting in the parentheses, which is why you got more points for that one. Okay? And I had several people who got this one. Can't remember if I had anybody get that far though. All right, I had several people who got close, but I can't remember at this point if anybody got that far. Okay, but that was the bonus question on the lab. Otherwise, I can't think of anything that I need to tell you. If you have not turned in that last set of openings, I have handed those back at this point, so they would certainly be a late grade if you are still planning to turn those in, because I have several people who have not given them to me. All right, other questions on papers that I handed back? No? We are on day 26 today, so we're a few weeks out from the end of the quarter. The end of the quarter is right around Halloween. I have no days next week to do makeup work after school. I'm not here Tuesday and Wednesday. For those of you who still have things that you need to make up, like missing labs, quizzes, and that, you didn't take advantage of the 3 days I was here this week. The following week, I'm thinking I only have 2 days after school. So get in here and get that stuff made up. All right, let's see homework. Let's see what kind of questions we have on that. No, I don't need to recover anything. All right, answers to... All right, so we did the back side. This should be the front. Whoops, that's the front. That's the back. There should be the answers to the back. Have we had long enough to check, or do I still need to wait? Can I turn? I'll give you nose out there. All right, there's 8 and 10. Yes, 6, 8, and 10. I think 6 was on the last page. All right, so which ones do we need to do? Any of them? Yes, ma'am.
2.
Number 8, and you said 2? All right, so 2 and 8. All right, so sodium is Na. Is it diatomic? So it doesn't get anything. And barium chlorate. So barium has a 2. Chlorate is ClO3, and it has a -1. So the 2 comes down. All right, we need the oxidation number to know who to switch. And sodium is a 1. So barium and sodium are both positive, so they're the 2 that are going to switch. So Na is going to be with ClO3, and Ba is going to be by itself. All right, is Ba diatomic? No, so it doesn't get anything. And this is a 1, and that's a 1, so they're going to cancel out. So I'm not going to bring those down at all. So I'm going to get rid of those. And I'm going to get rid of these. And that's what I'm left with. And then to balance, chlorate over here has a 2. So I'm going to put a 2 here to balance those. 2 sodiums, 1 Ba, 1 Ba.
I put mine in different order.
It doesn't matter. I mean, you can write Ba plus 2 NaClO3. They don't have to be in the same order. Okay. That's the same answer. All right, and you said 9 or 8, Denasia. Okay, so rubidium oxide is Rb. Rubidium has a 1, oxide has a 2. Bring your 2 down. Plus cobalt has a 3. Fluoride has a -1. Bring your 3 down. All right, this is double displacement, so who are we switching? It doesn't matter. Which one do you see when you look at it? I can do it either way, or talk about it either way. The who?
Fluoride and
Okay, so when you're switching the fluoride and the O. You're actually telling me to put the F with the Rb. Okay, so you're putting the Rb with the F, and so that means CO is going to be with who? Cobalt's going to be with who? Yes, cobalt's going to be with oxygen. Now, again, because there's no polyatomic ions, do any of these subscripts come across the arrow? No. All right, so now I'm going to put in +1 and -1, which will cancel out. And then +3 and -2, I have to bring those down. You see where I got the numbers? I got all the numbers from right here on this side. Okay, that's why I left them written here on the top so you can see where I got them from. You what? Use 2 for what? Fluorine? And then you're ready to balance. All right. Does that make sense? All right. Any other questions? All right. Without me having to go get my phone to look at what I took a picture of, tell me what the other 3 were. Tell me the first one. See what? H14, that was the one in the opening. So you get CO2 plus H2O, and then you'd have a 2 here, you'd have a 12 here, you'd have a 14 here, you'd have a 19 there. All right, next one. SR what?
CO3.
CO3. This is decomposition. This comes off your reference table. You have to match it to the formula. It matches MCO3, and you get MO plus CO2. So you're going to put M, which is SR. So SR with O, and then plus CO2. That's +2 and -2, which cancel out. And then you have that. And that equation is already balanced. You don't have to do anything to it. And what was the last one I gave you? C8H. 18 plus O2 goes to CO2 plus water, because that's, again, combustion. So we've got 8. We're going to put 8. We've got 18. there. We're going to put 9. That's going to be 16. That's going to be 9. That's going to be an odd number, so we're going to take those out. We're going to put a 2 here. 2 times. I ain't good. I was writing on it in one way. What? I don't know if this is computer rebooting in the middle of what I'm doing. Yeah. Go ahead. Call out the answer. I wasn't doing anything important.
2C8H8 plus 25O2 yields to 16 CO2 plus 16 H2O.
Yes, that is correct. I don't have time for this thing to reboot today.
That's the sign that we should be doing.
We test Tuesday. I don't have time for this thing to reboot. Y'all aren't gonna be happy when I mark questions wrong because you don't know how to do them. It's not gonna matter. All right, y'all need to find your reference tables so we can finish up decomposition and do synthesis today. All right, ABL and Lewis have come in, so while this thing is getting its act together, we mark them here. All right, so yesterday we were working on decomposition reactions now that the board has decided to behave itself. All right, so when we were doing this, we had reactions such as Let's just say that we have KOH. All right, with an arrow. Now, if we have a reaction like KCl, and then we have KOH, tell me the difference between those two reactions. How are they different? Can you tell me how those two are different? Okay.
One's a, no.
One's in the
I was gonna say one.
and one's in the south court.
Nope, one's not a chloride. All right, this one has,
Three elements.
there we go. This one has 3 elements. And this one has 2 elements.
So the difference is one's a polyatomic ion.
Okay? Yeah, one has a polyatomic ion and one doesn't. Now, if you only have 2 elements, what do you have to do to it? Just break it apart. Now, if you have 2 elements, you can look right here. Okay? This is the 2 element kind. So you can still use your chart if you have the 2 element kind. Do not write that on your blue chart. Okay? So if you have the 2 element kind and you're stuck and you don't know what to do, all right, you can write AB goes to A plus B. So what are we going to get? K plus Cl. All right. Now, anytime you wind up with single elements, what do you ask yourself?
Is it one of the?
Is it one of the 7 diatomics? Anthony's nodding yes at me. Are both of them diatomic? She's nodding no. So which one's diatomic? So we put a 2 on the Cl. Okay? All right. So from there, all we'd have left to do is to balance, and we would put a 2 and a 2. Here. Okay? Now, when you have KOH, you have 3 elements. We can't just break that apart into the element and the polyatomic ion, so you have to look where? You have to look between B through F and find the one that it matches. Okay? So which one does it most look like in B through F? Okay? So when you look at this, you're looking for the M, and then you're looking for the OH. Okay? Now, I told you yesterday, you could either find the pattern or you could look up the name. You could look up the name of OH if you wanted to, because then you could just look up the name to see which one it fits if you prefer. Okay? Most people don't do it that way, which is fine. It's not hard to look up M and then OH. Is this an M and an OH? Is this an M and an OH? Is this an M and an OH? That's the answer then. We're going to use this one to do our decomposition. So we're going to write M, or I am, MOH yields MO plus H2O. So now I just want to follow that pattern. So what is my metal? Potassium. And then I put what with the potassium? O. K with O. Plus, what comes next? H2O. Now, H2O they gave me. But this is a what? Is it an element?
No.
It's a what?
Compound.
It's a compound. What do we always do for compounds? Crisscross. Now, I told you yesterday, about half the time, what happens to the oxidation numbers? They cancel out about half the time. The other half of the time, they don't. So you got to check to see if they cancel out. K is a +1. O is a -2. 2 comes down. 1 comes down. So, did they cancel out? No. This time, if you had forgotten, you would have been screwed because they didn't cancel out here. Okay? So, is it balanced? Now, this time, how many K's do we have? So, I need to put a 2 here. How many O's did I make? 2. 1 O plus 1 O is 2. How many H's do I have? And I've got 2 H's. Questions? We'll try another one. We're going to have to do this in a minute. All right, let's say that we have all right, what can you tell me about the first one? All right, Chris says it has 2 elements. Yes or no? I see a lot of people nodding. So what do we do?
Break them apart.
Break them apart. So it'd be what?
And then,
Mn plus Br. Okay? If it's Mn plus Br, what do we do? Are either of them diatomic? Which one? We put a 2. All right, I'll come back and balance. All right, what does the last one look like? Got a polyatomic. All right. So we got 3 elements, got a polyatomic. Which one does it look like it matches? Which one? All right, looks like metallic chlorates. So it's got Cl and O. So M with Cl and O. Do we see a Cl? No. Okay, and that's a common mistake. Okay, it has an M with a C and an O. Okay, it's a carbonate. It's this one. Okay, so we've got MCO3 and it becomes MO plus CO2. So, who's my metal? Aluminum with who? Plus CO2. All right, so from there, what do I need to do? I need to crisscross. Aluminum has a what? And oxygen has a 2 comes down and 3 comes down. Let's get rid of that. And then let's balance. How many BRs? How many BRs? So I'm going to put a 2 and a 5. And then I need a 2. All right. How many O's are here?
9.
9. Okay, so we're going to have an odd number. Okay? So keep that in mind. Hey, Ms. Harvey. Are you a superhero today? You need a pink mask.
I know. I'll be looking real crazy with that.
You would. All right, so we've got 9 there, so keep that in mind because you're going to have to distribute. There's no CO3 on the other side. All right, so when you look at that, all right, look at all of the O's because you've got them in 3 places. All right, what do you want to balance first? Because your ALs are good. How many C's do you have?
1, 3, and then 1.
Okay, this 3 goes here, right? So we need to do what here? Okay, so if we put a 3 there, does it fix it?
Yes.
It does. Okay, because you get how many C's here?
3.
And that makes how many O's?
6.
And that's how many there?
3.
So 6 plus 3 is? And so we fixed it there and we have 9. All right, questions? Can we try synthesis? Because it works the same way. All you have to do is be able to read the chart. Okay? Now, synthesis, the only thing that makes synthesis different, all right, is synthesis does what? Creates. It combines two elements or 2 compounds. Now, this one causes issues for one reason. All right? This one causes issues for one reason and one reason only. First of all, the easy one is something like Na plus O2. Okay? What do you have? What's Na?
Sodium.
Yes, it's an element or a compound. It's an element. What's O2? It's an element. So if you got two elements, can it be single displacement? Can it be double displacement? Can it be combustion? Can it be decomposition? So what's the only thing left? Synthesis, okay? So that's why I said it's the easy one. When you go through the other four, you're left with, it can only be synthesis. So what's the only thing you can do if it's synthesis? Put it together, right? So everybody does Na and O. And because it's a compound, what do we all know we have to do if it's a compound? You have to do what? Crisscross. So +1 and -2. Bring your 2 down. Bring your 1 down. Okay? And then all you have left to do is to balance, right? So that was nice and easy. Now, the glitch comes in and creates issues with the second type that you might see. All right? So, what's the other one that causes problems? The two compounds is what causes problems. All right? So, let's say that you have this. All right? What does that look like to you? It looks like double, doesn't it? Okay, so let's say we just go through it like you did it last night in the homework. What's the first thing you do? Because that's what y'all are going to think. When I mix these up here, and we get to this mixed practice that we might just say for homework, and I'll tell you why in a little while. All right? When you have this in mixed, all mixed up, y'all are going to look at it and be like, oh, yeah, that's double displacement. So what are you going to do to it? What's the first thing you do? Find the oxidation numbers, right? So you'd say +1, -2, +1, -2. Who you switching? Na and H, okay? So you put Na with O, H with O, and then what's the next thing you do? +1, -2, +1, -2.
Exact same thing.
Exactly. Okay? If you get the same answer, it's not double displacement. Okay? So, if you try double displacement and you get the exact same answer, that tells you what?
It's wrong.
It's wrong. Okay? And it's going to happen. Because most of you are not going to recognize, oh, that's not double displacement immediately. All right, does everybody have what they want? So, how are we going to do it? Well, this is why we have that lovely cheat sheet in front of you. All right, so let me write it here. Na2O plus water. So we just predicted double displacement and we know we're wrong, right? So we pull up our blue sheet and we go to synthesis. This is the beauty in synthesis. We only have how many to pick from in synthesis? 3. So we've narrowed our choices. Now look at A. What was A? A plus B goes to AB. That was that easy one we did first, right? So we know it's not A. It's either got to be B or C. Now, is this a metal oxide plus water or is it a non-metal oxide plus water? It's a metal oxide plus water. All right, you got your blue charts handy? This is one of the few times you get to write on your chart. Because you'll know this by January. You just don't know it right now. Okay? Beside a base. Because you don't know what a base is right now. All right? A base is MOH. It's a metal hydroxide. Okay? So you get to write that beside the word base. You don't write it on your chart right now. Don't ask me during the test because I'm not going to tell you. Plus, it'll be here. Yes, ma'am.
So is this one like the, you know, how you said that it could be like the H2O and the H?
The base is
Is this
M
one
with an
that's
OH.
like them?
Huh?
Is this one like, this way?
Well, technically water can be an acid or a base. It's an amphoteric material, which is why water can be written as HOH.
Yeah, you lost me, or whatever, where did you say those?
Amphoteric.
Yeah, that.
Just means that water can be either an acid or it can behave as a base. Just write MOH beside the word base. Did you do that? Yeah. Okay. All right, so if we know that MOH plus water makes a base, here we're going to make it a base. So what's our metal? And we're going to put what behind it? OH. Now, this is still a compound, so what do we have to do for compounds? So plus 1, minus 1, what happened to it? I cancel out. Is it balanced?
No.
How many NAs?
Two.
How many O's did I make? 1, 2. How many H's?
2.
How many H's?
2.
Now it's balanced. Questions? Think you can try some? Fabulous. Remember, you're using your chart. We're going to do the odds. Yeah. All right, does everybody have a sheet? All right, we're doing the odd numbers, okay? First section is synthesis, second section is decomposition. And we're not doing this the rest of the period.
Did we balance? One of the ones before we said we skipped. You said we come back to it.
What we did.
Maybe I missed it. Did we balance that one? You said we skipped it.
Yeah.
If we didn't, just balance it. Everybody passed that quiz, so I know you know how to balance. How the soul failed. And I read nobody got below a C. Everybody did well yesterday. Nobody got below a 60. So unless we just can't figure out how to predict products, I'm feeling pretty good about Tuesday's test. But
I know I was going
now, let me point something out. You didn't crisscross any place other than with the H and the O. You didn't crisscross the oxidation numbers correctly. So when you put all that stuff together, you gotta look up oxidation numbers and crisscross. Okay? Now, when you put things together on the right, okay, because some of y'all are just gonna stick the letters together. What element has to go first, the positive or the negative? Positive. So when you write things like BRK, and I've already seen it on 3 or 4 papers as I just walked from there to here, okay? When you write BRK, which element is positive? Potassium. So who has to be written first? K. K has to be first, BR has to be second. Okay? I wouldn't take BRK because BR is going to be negative. Okay? K has to be first, then BR.
Did you say we were doing a positive or negative?
That's odd.
Okay.
I mean, if you do the evens, when I put the answers up, all of them are there. I'm just trying not to spend the rest of the period doing these, so I said just do the odds. And if you could do the odds, you ought to be able to do the evens. Maja, what time did you get here? I'm going to assume it was 9. I marked the target.
Wait. What time?
You got to be here for half class. To be counted late as opposed to absent. She's been here a few minutes, so we're going to go with 9. So if Jada shows up, she's just absent at this point because we're past halfway. Yes. You can't ask me first because it's positive. You look at your oxidation numbers. Look just like here. You look at your oxidation numbers, your first cross gas. Yes. And two. Right there, so you can go back and balance the equation. Same thing with your, if you're on a hub, you can balance the equation.
Is that for carbon?
Because in that one I did not specify, I would rate either on the answer you had both of them.
So what do we do if there's oxidation numbers?
Huh?
Like H2O2.
Yeah,
I know we do something with the ones at the top, or we do down at the bottom. Like, cause we're supposed to combine them.
yeah.
So H is,
The numbers at the bottom don't go across the arrow.
but why are they,
Huh?
why are they there?
Because they're diatomic when they're by themselves. But they don't get to go across the arrow, they go to the other side. The two stay on the left. You put H and O together on the right, and then you read crisscross their oxidation numbers as a compound. That two cannot be there because it's not diatomic by itself. Okay? When you put them together in a compound, they're not diatomic. You crisscross their oxidation numbers. So you want to look up K and yarn for oxidation numbers. Same thing here. When you put the twos there, look up H's and those oxidation numbers. Okay? So take those
I
twos
don't
off.
know.
Okay? And then that one you crisscrossed. And this one you crisscrossed. So you're fine with these two. Okay? Now, on this side, did you check to see if these or those were diatomic? Any of those elements diatomic? Yeah, they are by themselves. Are any of them diatomic? That was one of the cells. So that O is a two right there. Okay? And then that's why those two had twos on them. They're by themselves and they're one of the seven. The R is one of the seven. That's why it had a two. Okay? Now, crisscross and crisscross, look up the oxidation numbers. And then you'll be good. You can use it. Yeah. You understand what I'm telling you?
Yeah, but I don't know like how to tell whether I'm supposed to do one of these or just combine them.
It's just the combining ones because it's not a compound. They're singular elements, so you're just on A. It's an A plus B. Because in order to be this, it'd have to be a metal oxide. It'd have to be like H. It'd have to be like HO, like water plus something. Or like NO plus. You don't have any of that. Guys, don't just stop at synthesis. Keep going to decomposition. You're doing the front and the back, all the odds. Now you gotta do the left. And when you get down to the words, you have to write the left side in words and the symbols too. You can't just write aluminum plus sulfur and then symbols. You can't balance words and symbols. It's bad. I know. It's a heavy paper to turn over to check.
So it was done, that's it.
That's why I asked if you would turn the paper over. Yes. You're doing a good job, Louis. It's not 1-7, it does not give it 2.
So,
Yep.
is people are using like almost the same synthesis?
It's the opposite, they're backwards.
Oh, so it's a good and got everything like that.
Except that you got, where's your blue chart? You need it to be able to break some apart. You probably came in after I did decomposition. You're gonna need to be able to use you might as well pop it out of there. If you're gonna be using that a lot. Yeah, Alex. Yep, it's correct. Since you were so small. Other than here, you forgot that it was diatomic, it's 2, so it's balanced wrong, I don't see anything.
I'm getting confused. So it looks like the opposite. And you see the place.
Only the diatomic.
Square here and then -2. So then.
Technically,
I think it's
you can get rid of that and you can get rid of that because it's by itself. You only put a substrate on it. If it's one of the 7 diatomics, you can get rid of it.
So then it's just like a.
Yep. Correct. Almost. Oxidation. So, for the conceptual is 2, 1. It's oxygen by itself.
Oh, you'll see. Okay, so which one of those is? So here I do.
Yes, because it's by itself.
Here I.
Because it's by itself. Here, it's not by itself. It's 2 on there. All right, so here. All right, what do you think it's going to be? That's -2. So you can get it with -1. Yes. They are. You do that. Yes.
No, this
Yes. I did.
Why is it 3 years? You tell me to use 3 things.
No, it's because they crisscrossed. Aluminum wasn't 3, so the oxidation was crisscrossed down there. I mean, you could look at it that way in that you would use the 3 for aluminum, yes, but because aluminum is a 3, it crisscrossed down.
I would give information.
So I would just split them apart and I don't have to go to anything like that?
Correct. Because it's a 2-element compound, you just split them apart. I know you lost. That's what we did yesterday. Oh, excuse me, you missed all of that too, because you were making up the quiz for the Scurry taking you out of class.
And then the thing about it was when I got there, like my conversation only took 2 minutes, literally, like I was waiting on somebody else because it's. I'm gonna go in class the whole time.
Because this is a -2. There's no 2 there, so you know about carbon dioxide number. There's no 2 in that formula, where's the 2 go? So that means copper. Both 2. Yes.
I'm not gonna
Yes.
at all.
I didn't know what to say.
But that's why when most people, if they mess up and forget to put it in, it takes care of itself.
Hi, Angel.
I will today, because I should remember the answers. Basically, you're following these formulas. You see here, you're matching it to this. So you've got metal, carbon, oxygen. Metal oxide, which you have, plus CO2. Now you need, because this is a compound, you need the oxidation number. The oxidation number. This is -2. This is a +2. They're gonna cancel out. And then you can, okay? But you gotta fit the formulas, okay, for decomposition. So in the next one, like this one, KClO3, which one fits? KClO3.
You may want to be in.
Yep, so you're gonna make it MCl plus H2. Okay? All right, let's look at some of what you came up with. I know not all of you are finished. But I don't like to teach brand new content the day before a test, which is why I have that question mark beside mixed practice. Because I'd really like to start the activity series today so it percolates in your brain over the weekend. And then we can practice and review Monday all day. Okay? Because for some of you, the activity series will be the worst part of this. Figuring out if the reactions do or don't occur. All right, check your answers. Yes, ma'am. Huh? Think so. I haven't given them all away. Let's see if I have some in the back. My supply's gotten really low. right, can I turn the page?
Yeah.
All right.
Wait, why do you not have a, 2 subscript on 11 for CU?
Because the 2's reduced. If you look up CO3's oxidation number, CO3 is a -2. What happened to it? If CO3 is a -2,
No, I'm talking about the CU with the O.
I'm getting there. Okay? CO3 is a -2.
I can't talk.
Find carbonate.
Yeah.
Okay? It's a -2, right?
Not
in the formula. What happened to it?
It just, but I thought CU was a +1.
In order for CO3 to reduce, copper had to be a +2. So they're both +2s. They are both 2s. They reduce. They cancel out. So copper is a 2.
Okay.
Okay? So on the other side, copper would be a 2 and oxygen would be a 2. So they'd cancel
So
out.
how do you know to use the 2?
Because you have to figure out that it was reduced in the original formula CuCO3. Because carbonate's a -2.
So is that like what we did before? Yeah.
It's a previous skill coming back to bite you. Yes, Elmaja.
In 13, where you get the KCI plus the O2, where's the other O go? Is this 3 on that side?
I know you got to balance it to get rid of it. The formula that's on the sheet is MCl plus O2. So you write KCl plus O2. That's +1 and -1, so those cancel out. And then you balance the equation to come up with what you have. But you don't write O3, you write O2. O3 is ozone. We don't make ozone, we make oxygen. Okay? Can I turn the page?
How much money do you think I'll get?
How much money what? If you made ozone? What do you do when you make lightning? Lightning in the air makes ozone. I don't know. You might make a lot. All right, check the last of your answers. What? Yeah. Great. Oh. Come back, son. All right. What on this one? Anything? Now, your homework tonight is going to mix all 5 types of equations together. Okay? So you're going to have to figure out if it's single, if it's double, if it's synthesis, if it's decomposition, and then predict the products. Okay? And it's the biggest section point-wise on the test Tuesday. Okay? Point value-wise, it's the greatest section. Huh? The first section is balancing. The second section is either symbols or types, word equations, and then predicting, and then the activity series.
What symbols are these?
Those things I told you at the very beginning that we did the first day.
Triangle and arrow.
Oh.
And I told y'all to do.
Don't do it.
Don't lose 6 points because you don't know them.
I don't know.
I know. You got till Tuesday. All right. So we're going to talk about the activity series. Okay? Now, we've written a lot of equations over the course of the last week plus. Now, do all these equations that we've written actually react and make a product? The answer is no. Okay? We've written a lot of equations that don't occur, they don't react, they don't make anything. They just sit in a container and do absolutely nothing. All right, so the activity series tells us essentially the order in which elements react. Now, it is not the only thing that we use to decide if reactions occur. It is simply one tool, first of all. All right, there's something else we'll learn later in the semester to decide if reactions occur, but this is one tool that we can use to decide if a reaction is going to occur. All right, and it's on your reference table, so if you put it away, get it back out, because we're going to use it. Okay. Let me not do that yet. Now, we have to learn how to read the activity series. Now, in order to read the activity series, I want you first of all to look at the activity series. So, if you flip over your reference table, all right, if you're looking at the side that has all the reactions, just flip it to the next side. Okay, you don't have to turn the page, just flip it. Okay? And you're going to see a chart. Oops. It looks like this.
Wait, what? I didn't understand.
Okay? Looks like that.
I didn't understand.
Good ugly. Not that many words. Start late.
Yes.
All right, everybody got it now?
No, I'm almost done.
What'd you do? Start after her?
Most likely.
Come on, people.
I actually just. Okay.
Is there anybody else who's not done? I'll just sit and wait. Other than Denasia, who went to the bathroom. Huh?
I'm getting there in my life where I'm not knocking today.
Trying to be patient and work on it. All right. Now, if you look at the activity series, first of all, there's two ways we're going to read this. If you look at it, there are arrows. Okay, so the two rules we're going to write down, first of all, are going to make no sense to you. When we read this, the first rule is going to talk about reading these arrows. Okay, so I'm going to talk about arrows in the rule. And then the second rule is going to talk about, whoops, stay there. Is going to talk about reading the order of these elements. Now, this is the second time you get to write on your chart today. You will know this by January, so it doesn't matter if you write it down today. So on your chart, you can write H2O with an L. Let me change that since most of you will be like, what's that say? There. All right, H2O with an L is cold water. H2O with a G is steam. All right, replacing hydrogen from acids. Acids have to start with a hydrogen. Most of you probably remember that from middle school. But in case you don't, I'm being kind to you for right now. All right, you will know that by January when you take the exam because we will have talked about it many times. All right, and reacts with oxygen to form oxides is plus O2.
This is starts with hydrogen.
Yep, starts with hydrogen.
And what are those plus signs mean?
They're going to be in a reaction. Okay, so it's going to say like plus H2O is a liquid, plus H2O is a gas, plus starts with hydrogen, plus O2. Some of this we will not get to until Monday.
It's gonna be on text.
Yes. I'd really like to test Wednesday
Okay.
because of circumstances we're testing Tuesday. I won't be here Tuesday or Wednesday.
So are you staying for tutoring?
I can, as long as I don't have a meeting, I can be here. Right now, I do not have a meeting. All right, does everybody have it? All right, so the rules. So the first rule, all right, if we have water, an acid, or oxygen in the equation, all right, which is just a reaction. So if you have water, an acid, or oxygen in the equation, I could just as easily write reaction there if you'd like. Okay, so when I wrote equation, I could have written the word reaction there. Okay, we use the arrows on the activity series to determine if the reaction occurs. So if it says Na plus water, we have to use the arrows to decide if the reaction occurs. If it says Na plus HCl, HCl is an acid. We have to use the arrows to decide if the reaction occurs. If it says Na plus O2, O2 is oxygen. We have to use the arrows to decide if the reaction occurs. Okay? So you can choose to let them in or not.
Hey, oh,
All right, everybody got the first one? All right, the second rule. Will every reaction have water, acid, or oxygen? No. So the second rule, if there's no water, no acid, and no oxygen, the element that's by itself, or you could say the element that's alone, all right, must be above. All right, the element that is alone must be above the element it is displacing in the chart to occur. There's no water, no acid, no oxygen. The element that is alone must be above the element it is displacing in the chart to occur. All right, who am I waiting on? I got everybody now, all on the same page, caught up. We're rushing about. All right, so let's say that this is our equation, okay? And we want to know if this reaction occurs. Now, how do we decide? All right, how do we decide? It's got H2O as a what? As a thing.
There's a react
What's behind the H2O?
liquid.
As a liquid, so what's Devontae saying back there? Cold water, okay? So, we got water as a liquid, we got cold water. So we're looking right here in this range, okay? That range right there. And if you want, you can draw the lines in, okay? So, is zinc in that range? I heard like two people say no. Does everybody else see that zinc is not in that range? Okay, where's zinc at? Zinc is down here. Is zinc in the cold water range?
No.
Okay, is everybody with me on this arrow right here is the cold water arrow? Are y'all with me?
Yep.
Okay, are y'all too busy drawing the lines in? We'll draw the lines in before I talk again. I'm working on my patience today. Need to come to fourth.
Can I come to give away too?
No,
I just want to see what it's like.
it's like the depths of hell.
Who said
Yeah.
I see the one.
Mm-hmm.
Is that the one where the student spider fell off their shoe?
Yes, Stefan will be the one the spiders fell out of his
I
shoe.
figured it sounded like it.
That sounds like him. He said the truck that you hate.
I don't hate them. They just don't do any work. All right. So if you look at the section that has water as a liquid, okay, which is right here, all right, is zinc in this range?
No.
So our answer is no reaction.
Not really.
Definitely right.
Oh, that's. Does it get any harder?
Where's the catch?
The catch is if it's not no reaction, you have to predict the products.
What?
You just do what we've been doing for the last 2 days.
How do you do it with the S and the L?
It doesn't change anything.
So you
So
got
you
to
just
fit
erase
over.
it.
You just erase them or pretend they're not there. Okay? So, SN plus O2. All right? Which arrow has O2? Because this is oxygen, right? I go back. All right, I'm getting rid of all of this. All right. Which arrow has O2? The bottom one. This one's oxides, right? So that's this big long arrow. All of it. This is the oxide arrow. Notice what I colored in this time. So all of this is the oxides. Almost every metal reacts with the oxides. Okay? So is SN in that range? Yeah, it's in there, right? So if you answer yes, you predict the products, just like we just did. So ask yourself, is it single displacement? Is it an element plus a compound? No. Is it double displacement? Is it two compounds? Is it combustion? Is it a hydrocarbon plus oxygen? Is it decomposition with a one compound splitting apart? Is it synthesis? Okay, so it's the last one. So what do we do if it's two elements? Put them together. So we got SN and O. Okay, SN has a 2 and a 4. I didn't tell you which one to use, so y'all pick which one you like. All right, I heard more 4s, so we use the 4. Okay, but if you had said the 2, would I take off? No. Okay, so the 4 and a negative 2, we bring down a 2 and a 4. What happens to a 2 and a 4? They simplify to a 1 and a 2. Okay? And because you picked the 4, it would reduce. Now, if you picked the 2, you'd have had SNO because the 2 2's would cancel out, and you would need to say 2 and 2 to balance.
So whether it's a reaction or not, you always have to predict the product.
Say what now?
Whether it's a reaction or not, you always have to predict the product.
The only time you don't have to predict the products is when you say what?
No.
When you say no. When you say no, you don't have to predict. If you say yes, you got to predict.
Is this what you said all this way?
Yeah.
Why? It gets worse.
I don't think so, but people just don't like this section for some reason. Maybe y'all are just like it better than some people. I don't know.
Wait, count.
All right. CU plus HCl. Some people just don't like it every year. Some years I get this whole back. This is the back page of the test. There are 4 of them. Some years people leave the whole back page blank. Go figure. I don't know why. They just do. You know, in 4th period, I have some people who leave the whole test blank. They just turn it in blank. It's been a new experience for me. All right, 28 years. Never had whole people leave test blank. CU plus HCl. All right, what do we know? If we cruise over here, the whole acid section is copper there.
Did it have a special little like L or G or anything?
No.
For acids, it's AQ, but it doesn't matter.
Can I write that in? Like, is that an always?
Yeah, it will be AQ.
Because I would like to. What would it
It means it's dissolved in water.
That's aqueous.
Aqueous. All right, so it's copper in that section.
No.
So you write
No.
no reaction.
And you don't predict.
And you don't predict because you said no.
You can just write no.
You just write no. You can write no, but how about no reaction? All right. I'll come back to that one on Monday. Because we need to do one that's got one like this. Okay. So
What the? Oh, I got
now this one has no water, no acid, and no oxygen, right? So this is going to be the second rule.
Which one?
The top one.
Oh, okay.
All right, so when you look at this, we don't have any arrows, right? So what do we do if we can't read the arrows?
CFCD is above PB.
That's right, okay? The element that's alone, okay? The one that is alone has to be above the one it's displacing. The only way you can know that is to check your oxidation numbers. So CD is +2, PB is +2, nitrate is -1. So who has to be above who?
CD has to be above PB.
CD is alone. It has to be above PB
On the chart.
on the chart. So CD must be above PB. Then you would say yes. And what kind of reaction is this?
Displacement.
Single displacement. So what would you do?
Find the oxidation.
We've got them. Switch PB and CD. So PB plus CD, NO3, crisscross, +2, -1, bring your 2 down. Questions? Now.
This is another one of those dumb nuggets. It's not like directly beneath it, just like above it. On
Yes, just above it on the chart. Does not have to be directly. All right. Your homework is to predict products. I want that to percolate in your brains. Look at it again. We're going to work with it on Monday, along with predicting products. Okay? All. You're doing all of them. You're doing all 12, by the way.
Who is this for? Was it already balanced, just so I know if I did it right?
Yes.